thanks everybody. And as Ashish mentioned, my name's Cameron Presley. And if you're in the right Zoom meeting, you're here to learn a little bit more about LINQ and how you yourself could have built LINQ if only you known a couple of concepts. So a little bit about myself. I am the owner of a company called Small Batch Solutions. So this is an agency where we help companies just build better software. So if you're working with a company and or you're working on your own software, you're like, I wish this could be more effective, more efficient, hit me up. I'm guarantee we can figure out something to help you be more successful. I'm based here in Charlotte, which means that I'm enjoying all the fun summer heat that you all get as well. So that's cool. I'm also a Microsoft MVP. It does not mean I work for Microsoft or I get paid by them. All this means is that I do a lot of stuff for the community, and Microsoft has recognized that. So I love speaking to user groups, love speaking to conferences, and I'm really excited to be sharing some knowledge with you all today. Last but not least, I am also an amateur woodworker. This is like a workbench I built my first project, and it's terrible. It's not even, it wobbles, does all that stuff. But I show you this because when you go to learn and try to do something new, your first projects are also going to be bad. That's okay. Embrace the suck, if you will, here, right?
hmm
And just get comfortable with that. But
Yeah, I love that, Cameron. I think as we get older, we like feel like we can't learn new things, just because we get like just ingrained in how we do things, and we don't want to take on uh the the feeling of sucking at something. But yeah, I 100% agree with that. I just started learning golf like 6 months ago, and I just embraced sucking at it and learning, and I've figured out that I can learn new things, and it's actually fun. So
that's right.
I think your piece of furniture looks amazing. I would buy
Perfect.
it.
Shipping, though, shipping costs. That's where it gets you. Charlotte to Texas. On that note, though, here's some other good things. Let's say that you didn't want to take notes. Man, already got you figured. You don't have to. If you trust me, you can scan the QR code. But if you have any type of infosec or if you're an opsec person, you can always go to the URL blog.softwareministry.com/presentation. You'll find the slide deck. You'll find code samples. You'll find cool articles to read, the whole 9 yards. So what are we going to be covering today? First, we're going to spend a little bit of time to talk about what is LINQ. I like to spend a little bit of time here because a lot of engineers, especially those new in .NET, think LINQ is some entity framework. And yes, that's kind of related, but no, not really. From there, we're going to talk about what are the three pieces of .NET that, when combined, actually make LINQ work. And so if we're going to build our own version, we got to know what those three fundamentals are and how they interrelate. Last but not least, we're going to implement the three most common LINQ methods. I usually call it the trinity. So this is select, this is where, and this is aggregate. And I'm not going to show you how to implement it. We're actually going to refactor some code. So we'll actually end up refactoring production code to be into LINQ. And you'll see why once we do that, you're like, oh, well, this isn't too terribly scary. So I could go over some Wikipedia definition of LINQ, but I'm not going to. Let's look at some code. So let's say you've inherited this code base, and we've got this record called delivery team. They've got a name, a team lead, and a member count. So you can even suppose that this is for your team. And let's say we have the following data, right? We've got a collection of teams here. We got alpha team, we've got back to the code, we've got skill overflow exception, and we've got getting things done. And they're led by various people like Alice, Bob, myself, and Dana. And we've got some small teams with a count of 5, and then we've got a large team that's got a count of 10. And you've got a business requirement where that requirement is essentially, we want to find teams that have more than 7 members. So you go, all right, cool. Well, let's pretend LINQ doesn't exist. You may have written code that looks like the following, right? So we write some method called find two large team names, and we set up a list of strings, and we start iterating through using a for each loop, and we got an if check and all this fun stuff. And this code works. But here's kind of the problem with it. What are the actual lines of code that are important? And when I say important, I'm talking about business rules. There's a lot of code sitting here, but there's only 2 lines that are really important. Does anybody want to take a guess what they are? And you can either come off mute or you want to put it in the chat. Either one's fine. And if no one knows, that's okay too. I will give it a few seconds and then we'll keep moving.
Cameron, what was the question?
Yeah, so we have a whole bunch of code sitting here, but there's only 2 lines that are really important. If anyone want to take a guess like what the business rules were, because remember, we were trying to find which team names had more than 7 people on it. So if we take a look at that, these are the two lines that we cared about. Yeah, the team member count greater than 7 absolutely is one of them. But yeah, those are the two lines. But look at all the other boilerplate we had to write. That's kind of annoying. And the thing with for loops is you can do all sorts of stuff in them. So this could be a lot more complicated of a for loop. If we compare this solution to LINQ, same method, but take a look. My business rules, they're up front. They're right there. I didn't have to sift through a whole lot of things. And because we're using LINQ, there's some semantics there that we'll talk about a little bit later that also reveals the intent of what we're trying to do. So I find that when we use LINQ, the ability to shove the business rules right there at top instead of having to parse is actually a pretty good benefit, especially when it comes to reading other people's code. So if that's what LINQ is, let's talk about some of the other cool stuff. And to me, LINQ is interesting because it works on data and it doesn't care where that data comes from. It's totally independent of the source. It doesn't care if that comes from memory. It doesn't care if it comes from the database. It doesn't even care if it comes from a file. It just works on data. And you'll see that the way it does that is because it uses a very particular type of abstraction called IEnumerable. We'll get to that a little bit later. And the other cool thing about LINQ is not only does it work on data no matter where it comes from, it also is compiler type safe. So I don't know about you, but if you've ever had to freehand write SQL in .NET before, it's pretty rare that you were able to do that on your first shot, right? You probably wrote the string, ran the application, and then it blew up because you didn't like complete your where clause or something correctly, but you had to actually execute the code. Well, if we're going to make mistakes, we want to catch that sooner, right? We'd much rather catch it at compile time because if the code doesn't compile, there's no way this is getting shipped into production. Whereas if it's not compile time safe, you may be having your users catch it in production, and that's not always great, right? The other reason why I like LINQ, you end up writing less code. You end up writing less code to deal with, less code to read, less code to maintain. And we're not talking about playing code golf where we try to one line everything. It's just easier to work with. You just have to know what some of the words mean, and that's the trick. There's another benefit of LINQ too, that it's called the principle of least power. And this really awesome software engineer, you'd probably call himself a web developer, Tim Berners-Lee, describes the principle of least power as the following. When you're solving a problem and you're choosing a programming language, really common problem that you got to do, and you've got two like ends of the power spectrum. If you choose the low power end, it's easier to design, implement, and work, but you can only do so many things. If we choose the high power end, we can do everything, but that means you can do everything. So a really good example of this is a low power end of a language scale may be SQL, right? You can do all sorts of cool stuff in SQL, right? You can do selects, wheres, aggregates, filters. You can do all sorts of fun stuff, but it's not like you can make network calls. It's not like you can easily do like API things or manipulating file systems, right? That's not really what it's designed for. So because of that, you don't have to worry about those things. If we choose a different language, though, like C, well, C can do everything, right? It can manipulate file structures and make network calls and all that stuff. But that means you also have to make sure that you're doing all those things correctly. You don't have as much safeguards. And when I think about LINQ, that's its power, right? If we look at what can you write inside a for loop, it could do anything. It could throw exceptions. It could be logging to file systems. It could be manipulating state. It could be deleting your Win32 folder. It could be doing any of that stuff. But in LINQ, that's not true. You have to work really hard for it to break and do other things because at the end of the day, if you use where and select, it's only going to be able to do that one thing. It can't do other stuff. And so because of that, you don't have to error check as much. You don't have to do as much boundary checking, which is kind of nice. But enough about LINQ. Let's start talking a bit about the pieces that make all this work. And the first one is funcs, right? If we didn't have the func type in .NET, LINQ wouldn't work at all. There's a reason why when funcs got introduced to the language, LINQ came in the next version release. The second thing we're going to talk about are generics. It's always surprises me that generics were not in the first version of the language, but we'll spend some time talking about that and why that's important for LINQ. And last but not least, extension methods. This extension methods have started becoming a lot more popular in modern .NET, so we'll spend some time to make sure we understand those. So funcs are interesting to me because they're a data type, but they don't represent a value per se. They represent a computation. So let's take a look at a couple of examples so we understand what we mean when we say a func type. So for example, here is a func called getNumber, and it's not going to take in any inputs. And because we have that angle bracket int, that means it's going to return a number. So a possible implementation might look like this, where, okay, every time I call getNumber, I'm always going to get back the number 2. Pretty trivial. But funcs can take in inputs, right? So for example, we could write another function called isEven that says, if you give me an integer, I'm going to return you back a Boolean. And we can implement it like this, where we say, all right, well, if x mod 2 is equal to 0, you're even. And funcs can take in more than one input. In fact, I think the .NET runtime lets you write functions all the way up to like 8 or 9 inputs. It's a very high number. And your funcs can be more complicated. Here's an example of a func called repeat that says, if you give me a number and a string, I'm going to return you back that string repeated that many times. And here's some code that does that. I don't necessarily care if you understand the code I've written here and like inside the func, but as long as you can read that type signature, you're in a good spot. And if you're like, cool, Cameron, this is interesting, or I guess, but where do funcs come up in LINQ? You may not have realized it, but you've already seen it a couple of times in this presentation already. Remember this code from before, right? Where we're trying to find teams that are too large. Remember that where and select clause? That where, that's a func. This is a function that says, if you give me a delivery team record, I'm going to return you back a Boolean. And for select, that was a func as well. This is one that says, if you give me a delivery team, I'm going to give you back a string. The reason why we didn't have to formally say it's a func and all of that is that the .NET compiler is helping us out a bit. But let's refactor this code a little. Let's say that I didn't want to inline these. I actually wanted to assign these to variables. Especially helpful if you have a complicated where statement or a select statement. Cool, I can do it like this. Notice how I lifted them into funcs now with that more formal definition. This code works, this code still compiles because they're funcs. And we can even go a little bit further. Let's say that we're unit testing your code, right? And we want to put unit tests around is team too large and get name. We'd probably want those to be methods, right? Guess what? We can absolutely do that. So in this example, we've actually created methods and we're referring to them as that where and select. And that's because funcs can point to method, like they can refer to other methods. So there's a little bit of compiler magic to make that work, but from a developer perspective, it's functionally the same. So whether you've realized it or not, you've used funcs pretty much any time you've been writing .NET. Just maybe wasn't apparent. Pretty cool, right? So if that's it with funcs, let's take a look about generics, right? And T. Bracket T is very common in .NET for our generics. And let's talk about some inspiration and motivation behind it. So if you've written .NET for pretty much any period of time, you've probably used a list object, right? And so you've probably said list, angle bracket, and then some type, integer, string, delivery team. Well, guess what? Those are all generics. Anytime in .NET you see those angle brackets, you know you're dealing with a type that can handle generics. And generics are really just a placeholder. But let me show you maybe some real code. Let's say that we're working with a product and our product team, and we need to implement a queue structure, right? And queues have certain properties that needs to follow. And we implement a queue that handles numbers. So we go, all right, we're going to use a list of int to model that under the hood, but otherwise same thing. We've got a constructor that sets the elements to an empty list. We can add stuff to that list, and we can remove items from lists. And even look, we throw exceptions if you try to pop an empty queue, right? All the fun stuff. And this code works. But then requirements change. And now we also need to not only support numbers, we also need to support strings. So you might go, all right, cool, no problem. I'll just copy and paste the code and write a string queue. But we're engineers, right? And engineers are typically pattern oriented. So if we take a look at these two classes, they look really similar. In fact, if we ignored the name differences from number queue and string queue, there's only one difference. And that's the types, right? Other than that, the code's exactly the same. When we find ourselves writing code like this, where the implementations are all the same, it's just that the types are different, congratulations, that's generics. So let's refactor this to use generics instead. So we're going to define a class called Q, and we're going to add that bracket T at the class level. And the way to think about that is you're telling .NET that for this class of Q, wherever it sees a T inside of the class, refer to the same T at the definition level. So when we say T here, we mean T everywhere else, and it's the same type. Can't be anything different. And what's cool is that once we set up Q to be this way, instead of having a number Q type and a string Q type, those classes, throw them away. We don't need it. We can just reuse Q. This is a pretty powerful technique because it drastically reduces the amount of code you have to write. And it still kind of floors me this wasn't in the first version of .NET. Going back, you actually had things like array list, and you had to actually make like a number version and like custom versions. And some languages today still don't have generics. GoLang is the most common one that I know that community is still figuring out if they want generics or not. But if you understand that generics allow you to pretty much reuse the same implementation without having to copy paste, you kind of understand what we need to do here. The last part that really makes LINQ work is this idea of extension methods. So as we've been doing, let me show you an example of what one could be. Let's say we're working in a code base and we've got a requirement that says, hey, when we're viewing the report, the format for today's date should be in this very specific format, right? Year, month, date. And we go, okay, cool, no problem. We say, sweet. We set now equals datetime.now, and then we say the formatted date is now to string. Here's the format. And this works. This is great. In fact, we're kind of a victim to our own success because now our product owner says, hey, now we have a problem because in some places of the app, we have dates in the year, month, day, but in other places we have it month, day, year. Can we be consistent? And at first you might be thinking, oh goodness, man, we've got a lot of copy paste that's about to happen here. Well, not necessarily. What you might think about doing is instead, let's create a method that handles this. And then we just use that same method everywhere. That way, if we do have to change it in the future, we're only changing it in one place. So we do that. So we create this static class or the static method called format date for display. You pass in a date time and it will format it. This works, no problem. But you might notice that when we're now refactoring to clean up everywhere, our code looks like this. We're having to do this date formatter dot format date for display. And that looks a little bit clunky. It would be very nice. And the other problem with this too is that there's some discoverability happening, right? You have to kind of know that there's a date formatter class running around. And if you don't know that, then you wouldn't know to do this. So it'd be helpful if we could do something else. Well, this is where extension methods come in. So you may recall this is our date formatter class with its method from before. We're actually going to extend and actually attach this method to the datetime object itself. And we can do that really simply by adding the this keyword in front of that first parameter. The minute we do that, .NET will recognize, hey, date time anywhere in this project, it has a method called format date for display. It'll show up when you do IntelliSense. It'll show up in your autocomplete. That just automatically works. And once we make this small tweak, if we come back into our example code, we can now say anywhere we have a date time, we can just say now dot format date for display. We don't have to remember to carry around that object from before. Now, this might seem like a simple example, but we actually use extension methods all the time. And it's really important for LINQ because if you look at the Microsoft documentation for extension methods, it actually calls out that the most common ones are the LINQ query operators because they extend off IEnumerable and IEnumerable of T. And that's powerful because since they extend off IEnumerable, if you write any code that returns back or works on an IEnumerable, you get LINQ for free. You don't have to do any special work. You get all of that capability for free just by coding to an IEnumerable or an IEnumerable of T. That's crazy. There are very few languages that have this style of like powerfulness baked into the language runtime. Very, very few. Um, it's just insane to me that we get that. But when extension methods came out, that really kind of made LINQ sing. And if you're like, okay, cool, I like LINQ's interesting, but what else do we use it with extension methods? How many of y'all are writing ASP.NET Core nowadays? Are any of you registering dependencies using the service collection? Guess what? Those are extension methods. How about the built-in logger in .NET where you're taking that iLogger? Do you do things like log warning, log error? Yeah, those are extension methods too off the iLogger interface. So I kind of hinted at this before, but using extension methods is a more common technique that Microsoft's using, and it really does help tidy up code bases. So if you're not familiar with that concept, that's definitely something I'd spend a little bit more time on. At this junction, we've talked about a lot of concepts, but let's actually start getting into the coding side of this, right? We're actually going to write our own version of LINQ. So, but there's a couple of restrictions we're going to put on ourselves. The first restriction we're going to put on is that whatever we write, it has to work with IEnumerables because Microsoft's LINQ does. So if it doesn't extend IEnumerable, we've got a problem. It's also going to have the same type signatures of LINQ. That means it's going to take in the same inputs and outputs as LINQ would. Because if it doesn't, then it's not the same thing as LINQ, and that's a problem because that's what we're trying to emulate, right? And the last thing we're going to do is we're going to make sure it has the same properties of LINQ. Now, the first two make sense to a lot of engineers, but I find that a lot of engineers don't really think about LINQ in terms of properties. So that's something we'll spend some time with today as well. And let's go and get started and talk about the first one, where you're changing from one type to another using map. Now in .NET, this method is called select. I can go ahead and tell you though, in every other language, it's called map. Microsoft's the only one that calls it select. And I really truly believe it's because they were wanting to follow the same SQL Server, SQL query language syntax. But let's take a look at what select and map really do. So the problem you're trying to solve is you've got a collection of one thing and you want to change it to a collection of another type. And you can do that if you pass in some type of mapping function that knows how to go from that one type to another. And that's a whole bunch of words, but let's break it down. So if, for example, if I had a list of numbers and I want to go to a list of strings, map would be great. And there's some really cool properties that you get with map. The first one is you're guaranteed it maintains the length of the collection. If you call map or select on an empty list, you're going to get back an empty list. You call it on a list of 5 items, you're guaranteed to get 5 items back, not 4, not 6, not 2. That's pretty cool. If you're doing that with the for loop, that's not always guaranteed. You're also guaranteed that the results are of the same type. So if we were going from a list of numbers to a list of strings, you're guaranteed that that list of strings, they're all strings, not some of them are strings, some of them are Booleans, some of them are custom objects. Nope, you're guaranteed that they're all the same strings because if they weren't, your code wouldn't compile. And if you somehow figure out a way around that, let the .NET team know because that's an interesting one. The other nice thing about using map and select is that whatever collection you get back, it can't be null. So that means you don't even have to add error handling logic there when dealing with these lists, right? Or dealing with LINQ statements because it can't be null in this case. Pretty cool. So let's kind of refactor into our own version. So we had delivery team from before, same record. And we were given the task of like, hey, we got to see all the names, right? We want to find all the names for all the delivery teams we have. So we go, all right, cool. And we write this code. And this code works. But then we find ourselves that we need this information in lots of different places in the code base. And then we go back to our thinking and go, okay, well, I probably want to centralize that, right? Make one shared method so that way if we need to update it, we update it one place. So we do that. Well, if we're going to do that, we can actually make this as an extension method. This time it's extending off the list of delivery teams. So anytime that we've got a list of delivery teams, we can say teams.get team names, and this will work. No problem. But once again, we're kind of a victim of our own success. So this works so well that we get another requirement where we also want to see the team leads for those teams. And you go, all right, I've seen this movie before. So we write another extension method called get team leads. And it's going to iterate through the list of teams, get the team lead, and add it to our list. But so we've got 2 extension methods. and we take a look at them and we go, goodness, these look really similar to one another. In fact, if I ignore the method names, there's really only one difference between these two methods. Anyone want to take a guess what the difference is? So the difference between these two is what we're adding, right? In one case, we're adding team name. In the other case, we're adding team lead. Otherwise, the code's exactly the same. So let's refactor this so that we're not having to duplicate so much boilerplate. So what we're going to do is we're going to create a new extension method called getStringValues. And what we're going to do is we're still extending off the list of delivery teams, but what's different is we're going to add in this func. And this func says, if you give me a delivery team, I'll return you back a string. So we go, great. We use the getter. So whatever the getter returns back, that's what we use. And if we go back to refactor get team names and get team leads, that code in green, we can throw it away. We can just say team.getStringValues, team.name or team.lead as needed. Pretty powerful, right? Because we got to remove a lot of boilerplate code and have all that stuff in one shared place. So we pat ourselves on the back going, good job, right? We've removed some duplication. Once again, though, we are a victim of our own success because now we get another requirement saying like, hey, we actually need to know the number of people on each team. So we go, okay. So we write a new function, new extension method called getTeamCount, and we're just adding the counts to the list, right? Looks very similar to other code we've written so far. And then we go, let's go ahead and refactor this a little bit more. And we end up having an extension method called getIntValues. The problem, though, is we look at this code, we compare it to getStringValues, and we go, wow, this code looks really similar to each other. Incredibly similar. In fact, the only difference besides names are the types. Well, shoot, if the only differences are the types, we know how to do that. This is where generics come in, right? So what we can do is we can create a new function called map that takes in that T result is the generic. So anywhere we had int, now we just refer to it as T result. And I know it's a little bit bulky of a name T result, but you'll see why in a little bit, why we went with that name. But cool. So we put in T result and this code will still type check, it still compiles. That get string values and get int value methods we had before, yeah, throw them away. We don't need those anymore, right? Map can do that for us. So we toss out this code. And now our get team names, get team leads, and get team counts, they're just using the map method instead that we built. And notice how this would all still type check, it would all still compile, no problems. So that's pretty cool. Here's the fun part though. Given how map looked, so I'm going to go back a little bit. Given map, is there any reason why this would only work on delivery team? Do we see anything inside the method that refers to the delivery team type? Nope. There's not a spot for it. The only place we actually mention delivery team the type is in the func and in the list. So if that's the only place we ever use it, we can make that generic. So in this case, we're going to call it T source. So we say, all right, map takes in a list of any item of type T source. And if you give me a function that can go from T source to T result, I'll give you back a list of T result. Same code as before, it still type checks, right? No problem there. And this is really kind of cool because if you look at the Microsoft implementation for select, it's the same code. And it has to be the same code because there's no other way you could have written select or map in our case that fits all the properties and still type checks and compiles. Now, you'll note that this method is called toList. That's because Microsoft has some performance tuning, whether you're doing like toList versus toArray versus toDictionary of that such. But it's the same implementation. The only difference is that we call ours mapper, they call theirs underscore selector, but it's the same thing there. And I think that's pretty cool. The problem, though, is that we're still working with lists. And I mentioned that we've got to do IEnumerables. So that one's actually not too bad to do. Instead of tying off to list, we tie to IEnumerable. And then we use the yield return keyword to go to kind of stay in that IEnumerable context. This is going to be a little bit slower just because of how IEnumerables work. That's why Microsoft has that performance tuning on whether to go from a to list or to array. But this would work, right? You'll still get all the same behavior characteristics, everything that you would expect of LINQ. And because it's signed to IEnumerable, it'll work with anything that's an IEnumerable, which I think is pretty cool. Oh, big thing to remember about map is you use it when you're going from a collection of one type to another type. That's it on that side. Let's take a look at the next one. Keeping what's needed with keep. So Microsoft calls this method where. And this is one of the times where I think Microsoft chose a really great name because most other languages call this one filter. And I don't like the name filter because it's not very clear. Are you filtering things in or are you filtering things out? So unless you figure that out, it can be a little bit confusing. So in our example, we're going to call ours keep. So what where filter and keep does is that it gives you a subset of a collection based on some criteria known as a predicate. A predicate is a special term for a function that returns Boolean given an input. So where has a lot of really cool properties to it. The first one is that whatever collection you get back, its length is somewhere between 0 and the original length of the collection. So if you call where on a list of 5 items, you're going to get back somewhere between 0 and 5 items. You can't get back 6 because it can't create something out of nothing. And if you're able to create a list with negative numbers, come chat with me because I'm really curious how you pulled that one off. It can't return items that weren't in the original list. So for example, if let's say we were trying to get all the even numbers between 1 and 10, it can't give me back 12 because 12 wasn't in the original list. It can't give me back 20 because it wasn't in the original list. That's pretty powerful. It also maintains the order. So if the order of, so if my order was literally 1 through 10 and I'm trying to get all the evens, it has to give it to me in 2, 4, 6, 8, 10. It can't give me 8 first, then 4, then 2. Can't do that. Wouldn't work. And I don't have it on here, but the last thing, it also can't give you back null. So once again, the worst thing that would happen is if you got back an empty list, but an empty list isn't null, which means you don't have to add null checks, which is great. So let's do like we've done before. Let's actually write our own version of where, calling it keep. So here's our delivery team object from before. And we get a new requirement because we want to make sure that we don't have any delivery teams that are too big. Too big in our case is a team more than 7 people. So we go, all right, cool. I'm going to short circuit some of our logic here. We're going to go ahead and write the extension method. We're going to go ahead and target the IEnumerable type. But other than those two things, here's the code. We say, cool, we're going to go through teams. If the member count's greater than 7, return it. That works. Code compiles. Hip, hip, hooray. But we get another requirement that says we need to figure out which delivery teams are being led by Dana, because we want to make sure that Dana doesn't have too many teams that she's having to lead, because that can get really tiring. Just the one-on-ones alone seem tiring to me on that. So we write code that looks a lot like this. Another extension method. We iterate through teams, and we check if the team.team lead is equal to Dana, and if it is, we return that team. So we have these two extension methods, and if we take a look at them, we go, huh, these look really similar to each other. In fact, really the only difference is that if check, right? Otherwise, exactly the same. So if the only differences are those if checks, we know a technique on be able to pivot that or allow that to be controllable, right? Let's use funcs again. We did in the last one. So we create a new extension method, I should say, called get teams by. It's still extending off the IEnumerable of delivery teams, but it's also going to take in that predicate func. And instead of having the if statement hard coded, whether it's looking for a member count or a team lead, we're just going to call the predicate. Right. And if that predicate returns true, we return back the team. And if not, we throw it out. No problem. And this works. No issues. And we can go back and refactor or get too big of teams get rid of the code in green. We just say, cool, teams dot get teams by member count greater than 7. And then for teams led by Dana, very similar. We just put the business rules inside the func that's being passed in. And then we can toss out the commented code. So this is the code we have, but it's kind of the same question from before. If we look inside the get teams by, there's nothing in here that explicitly is looking for the delivery team type, right? It's not in here. The only place we ever mention delivery team is in the method signatures. Well, if that's the only place they're being mentioned, that sounds like we could probably genericize that, right? So let's do that. So here's our final implementation of keep, where we went from delivery team to that T source. And notice how all those changes were at the method level. The actual implementation itself stayed exactly the same. Pretty cool. So if this is our version of keep, here's Microsoft's version of where. Once again, they have the same performance tuning thing where it's the two list implementation, but otherwise it's exactly the same. And here comes the fun part. Is there any other way that we could have implemented where such that all the properties that we talked about earlier would be true, like they would all be followed? And I'll give you like 100 like fake internet points if you know the answer to this question. Okay. There's only one other way we could have written where such that all the properties were true. And I kind of hinted at this. Do you remember when I said that filter is a really bad name because you don't know if it's filtering in or out? What if we negated the predicate check? If we said not predicate? That's the only other way you could have implemented this, which goes back to why I think filter is a bad name for it. But we implemented where, and it works like a top, which is pretty cool. If a lot of this didn't click, that's okay. The big thing to know about where, or keep in our case, is that if you've got a collection of items and you're only wanting some of them that fit some criteria, you need to use where or keep. That's the method you're looking for. Third but final, let's talk about reduce. So reduce, it's called reduce in almost every other language. In Microsoft, it's called aggregate for LINQ. And the idea behind this is that you're taking a collection of many items and turning into one thing. So imagine if you had this basket of eggs, current market value $30,000, and you're turning it into this delightful breakfast frittata. That's really what reduce and aggregate are doing, right? But the code for this can be a little bit interesting. So I'm going to show a more introductory example. Let's say that we were wanting to get the numbers between, we wanted to sum up all the numbers between 1 to 10. So how aggregate works is that you need two pieces of info. You need the initial value, and then you need something known as the reducer. Now, the initial value, a good way to think about that is, hey, if the list was empty, what would the answer be? So in our case, right, if we're summing up the numbers from 1 to 10, but somehow our list was empty, what's the total of an empty list? It'd be 0, right? So that's why that's my initial value. And then the reducer is a function that says, cool, if you gave me the initial value and you gave me an item off the list, what's the next item? Like what's the result? Like how do I combine those two things? If you can write that, then you can use aggregate. So in our case, initial value is 0. The reducing function is addition, and this will work. Now, aggregate's really powerful because you can write all sorts of cool stuff with it. But the problem is that it can also get a little bit complicated to read. And so let's go build out our own version. Looking at the chat, yes, Daniel, I appreciate the pun. Unfortunately, you got the wrong camera. You got the wrong C name. That's absolutely Jeremy. So Alex, thank you for putting him on blast. I appreciate you, sir. So let's say that we had this requirement of how many people do we have total throughout all the teams? We might write code that looks like this, right? Still an extension method, still off IEnumerable, but this is a very common summing total loop, right? We set total equal to 0. We're going through teams, we're adding member count, returning the total. Very straightforward. You've probably written this code a million times. Let's say we have another requirement, though, where we want to build out a list of formatted team names. So we build something that looks like this. We're not doing anything with numbers, right? We're using string builder because we know that when you're concatenating strings, you don't want to do that with just plus. You need something, otherwise you run into some performance issues. So we go, cool, we're going to create a new string builder. We're going to set up like a basic line, teams in the company. And then for every team in the list, we can cat to it the team name in like some markdown format. And then we return back the string builder. So both methods work. And if we take a look at this code, these two methods have almost nothing in common, right? Yes, they're both static extension methods off delivery teams, but that's it. One's dealing with numbers in addition, the other one's dealing with string builders and append lines. Like there's not much in common. However, there's still a pattern between the two of them. They both set up some initial value, and they both have some way of adding to the initial value with the new thing. And they both return the result of that combining. You ever write code that looks like this, you've actually got a reduction hiding. And in fact, this is, I'm going a little bit off topic here, but not time. This is also a functional design pattern. For those of you who get bored and look for something to do on a Friday evening, look up the phrases category theory and then monoid. But if you have an initial value and some way to combine it, you actually have a monoid, and that allows you to do some really cool things. You can think of a monoid as a design pattern, just like a factory pattern or a singleton pattern or any of those other ones. It's just that it's a functional programming concept. But so we've got a pattern here. How do we refactor? So here's what our reduce would look like. Now, this is a pretty rough type signature, so bear with me here a little bit. So because it can return an integer in one case and a string builder in another, that means we got to make the return type generic. So we're going to use t-result. Once we have t-result, we also know that's what the type of the initial value that you're passing in is, right? Because if the list is empty, this is what we would return back. So it's also got to be t-result. Then for that reducing function, it has to be something of the signature, given what I had before of type t-result and a delivery team. Here's how we combine those two things together. Once we have that function, the implementation is we set the initial value, we update result with whatever the return of the reducing function is, and then we return the final result. So this works, but let's take a look how this would look in application. So here's our total number of members again. We set our initial value to 0. We set a reducer function to be some func that takes in an integer and a delivery team. Integer is called ACC, delivery team is called item. And then we say, cool, take whatever my accumulation is, add the member count to it. That's the result. And then once we have the reduce function, we can just call the reduce method. No harm, no foul there. If we keep taking a look at formatted team names, our initial value in this case is what would we get if the list of teams was empty? Well, it would be this new string builder with teams in the company appended to it. And our reducer in this case is some function that has to take in a string builder, because that's what our initial value type was, a delivery team, because that's the thing that we're iterating on. And for our, how do we combine these two? We say, cool, a string builder, append line, whatever the item name is. And since we have the initial value and the reducer function, we can use the reduce method, and that will work. So with these in play, here's our final version of reduce. Same question as before. Is there any reason why this is stuck on delivery team? And the answer is, well, no, not really. Because if I look inside the method implementation, we never refer to the delivery team type ever. It's only in the method signature, right? The thing that we're extending off of and the func. So let's switch that out for a generic. So we go from delivery team to T source. And once we fix it here, that's it. We don't even have to update the method implementation. So that's pretty cool. Now, the version on the left is ours. Here's the Microsoft version of it. And it's funny because they have some if null checks here. But if you ignore the if null checks, the code looks pretty much identical, and it kind of has to be, because once again, there's not really any other way you could have written aggregate such that it follows the type signatures and the properties. It has to be this. So just like that, we kind of wrote the three big like LINQ operators, and we didn't have to like work from scratch. We was able to refactor code into this. So that's pretty cool. Now, the thing to remember with reduce is that it allows you to transform a collection to a single value, right? So you're taking a big list of items and turning it into something else. But a lot of people think that this means you always go from a collection to a single item. That's not true, because, and we're going to do it today, we're actually going to rewrite everything we've done in LINQ today using reduce. We're going to go back to map. We're going to go back to keep. And you might be thinking, what, Cameron, that's crazy. We can't be doing that. Oh, absolutely. We're absolutely going to be doing this because I mentioned this to you earlier. Reduce is kind of universal. You can rewrite all of LINQ in terms of reduce. Now, is the code you generate the easiest thing to follow? No. Should you do this in production? No, not unless you really hate your coworkers. But is it a good thought exercise to see how all of this works? 100%. So let's go for it. So if we're going to map these things, right? If we're going to convert them in terms of reduction or reduce, there's two questions we got to solve. What's the initial value? And then how do we combine that initial value with an element from the list? If we can answer those two questions, we can use reduce. So let's look at map. So here's our original implementation. So first question, what's the initial value? And if you remember about the properties of map, it gives you back a list of the same size that you started with. So what happens if you call map on an empty list? What would you normally get? You get back an empty list, right? Because it maintains the size. So we're going to cheat a little bit, and we're going to use this thing off the enumerable type called .empty. But that will give you an empty list. So we've got that. So here's our map via reduce. So our last statement is always source.reduce initial value, comma, reducer function. The minute I put that line in there, I can use ReSharper or VS Code or Visual Studio, whatever your editor choice is, and it will generate me the reducer signature. So if we can figure out what to put inside the reducer signature there in the blank space between the code braces, if we can figure that out, we've got this. So here's the question we've got to answer now. We've got to figure out some way to convert the T source, which is our item. We got to convert it into a T result. And once we've got that, we've got to add it to the accumulation, the ACC. So step one, is there anything that we have access to that knows how to go from a T source to a T result?
Your selector func. Yeah.
Bingo. That's right, Sharon. Absolutely. So our selector knows how to do that. So cool. Let's use it. So we say, all right, cool. Well, our converted item is whatever the result is from the selector function. So that will work. And then we're going to add it, and we're going to cheat and use the append operator that exists on the enumerable type. But that's it. We just rewrote map in terms of reduce. Now, is this easier to read than the original version? No, absolutely not. But did we do it? 100%. Let's go to keep. So same questions as before, right? We got to figure out what its initial value is. So if you were to call keep or where on an empty list, what would you get back? It's got to be an empty list, right? It can't be anything else. So we're going to use that enumerable.empty. Same trick from before. Through the power of slide decks and some movie magic here, we get this code. Same type signature, same everything, but now our reducer function is going to be a little bit different because we first got to check to see if the item meets the criteria. In other words, do we want to keep it or not? And if we do keep it, we've got to update the accumulation. Otherwise, we don't need to update. We just return what we've got. So to pass step one, we got to find something that we can use that says, given a T source, our item, it returns back a Boolean because we got to put this in part of an if check. And the good thing is we actually have something that does that for us, right? It's that predicate function that was passed to us. So let's use it. So we plop that in. Now we got their if-else branches. So now the second step is, hey, we've got to add an item to the list, right? We got to add an item to the ACC. How do we do that? Well, if we recall, we have the append that we used in the select, right? So we can use it here. All right, cool. So that will return back a new IEnumerable with an item appended to it. And that makes sense because we wanted to keep it. And in the else condition, we just return back the accumulation unmodified because we don't want to add anything to it. Once again, is this easier to read than the first version? No, absolutely not. But did we rewrite this in terms of reduce? Absolutely. And to me, that's kind of the powerful thing about like learning reduce and such, is that once you start seeing this pattern, start thinking about it, you can start seeing it everywhere. So you can actually reduce a lot of complexity in your code base by doing that, which is kind of nice. But with that, that does hit kind of the meat and potatoes of today's presentation. So as a recap, what did we cover, right? We talked about what LINQ is, right? LINQ is a really cool set of operations that work on data no matter where it comes from, that's compile time safe, which is dope. That's fantastic. It means we catch errors sooner without having to deploy it or having to run it. We talked about the three fundamental concepts that actually make LINQ work: funcs, generics, and extension methods. If we did not have these three things in our language, we could not make LINQ work. Also pretty powerful. And then we spent today implementing map, keep, and reduce. And then we went back and implemented map, keep again. We went part 2 with reduce, which is pretty cool. The big things to remember, though, is if a lot of this was like too much .NET or like a little bit complicated, the real thing here is LINQ's not magic. It's not some proprietary thing from Microsoft that you could have never figured out. Like, no, it's not black magic. It's a composition of some techniques, funcs, generics, and extension methods. And by doing that, that allows us to build these bigger applications. And with that being said, thank you all so much for the time today. I really appreciate it. You can always drop me a line at Cameron@softwarementor.com if you got questions, especially after the presentation. And here's some links again to where to get the slides and resources as needed. But I really appreciate your all's time today.